So you're here to talk about Python. Well, let's get started then. My name is Michael and I'm from Pixeesoft. Welcome to our channel. Here we talk about software development, agile, and yeah, as I always say, everything in between. So thanks for tuning in and welcome. So this is actually the very first stand-up in our third sprint. That's right. And we moved on. We deployed all our API-based services, and now we're on to the good stuff. We're on to Python, and those are hefty components of the whole solution. And I have to say, I already know in advance that it's going to be a ride. So every good stand-up should have or be accompanied by a Scrum board. So let's jump right into it. And as you can see, there are already some things in done lanes. And you might be asking, how is this possible? If this is the first stand-up, how come there are already things that are done? Well, due to the timing of the release of the videos, of the sprint planning video, I basically had to wait a day for it to go live, mainly because it would just be strange to do a quick sequence of one video late in the afternoon on Tuesday and then another one right Wednesday in the morning. It might feel a little overwhelming. So I said to myself, all right, I'll skip one stand-up stream and I'll start working, and then I'll just catch up rather than just sort of mocking it and not telling you the truth. I opted, I'm just gonna come clear and say what has been done. And so in fact, what I worked on, other than the Python component, was reducing the size of the cluster, of the Kubernetes cluster for the API services, mainly because it got a little too expensive. And frankly, I do have the calculator open. If you take a look right here, this was the cluster that I defined for each API service, and that's quite a price for one service, right? $100 per month. And why is it so expensive? Well, first of all, it's quite big. The cluster has 3 nodes, and each node is standard size, which you can see right here is 3.7 gigabytes of RAM. Combined, that's over 11 gigabytes. That's really way too much for what it actually does, which is just a passive API service. So in fact, what I worked on was that I reduced it to size 1, which it defeats the purpose of it being a cluster. It's just one computer, but the reason being is that each service lives in a separate cluster. Once I refactor or once I actually rewrite each service, all 3 of them, OAuth, billing, and the resource API, all of them can live in one cluster. So eventually it'll be down to one cluster that has 3 nodes, and it will be much cheaper all combined. Mainly that is because I would have to have a 3rd cluster right now for the billing service, but the billing service is mocked and it lives in Cloud Run, so that's why it's not here. But $100 per service times 3, that would be $300 per month, and that's just the API. That's just unbearable. Whereas right now I'm down to $30 per month, so that is 60 in total plus Cloud Run, which is basically on demand. Then it would be 90. Yeah, I think that we're down to something more reasonable. Okay, so now back to Python. I suppose that's the reason you're here. Well, we have to create a container for the data feeder. That's the component that feeds the clients the data, that pushes the data into the iOS app, the Android app, and the web app. Now, this is the one that I have to start with because this is the reason why the web app and the mobile apps are not running right now, because they're trying to connect something to something that doesn't exist. So that's why I need to focus on this one. there is some issue, or there are certain caveats that come with deploying this service. It's a Python script. It's right now deployed via init.d files. It lives as a daemon on a server, which is perfectly fine, but it's not suitable for our deployment in a Kubernetes cluster. So what needs to be done? In fact, the init.d scripts need to be just stripped down, and I need to find the specific task that I would put into a Docker container that's running Python, so that the entry point to the container would be that one line, that init.d script, or that one command that runs the code. Each Python script that actually is the component is actually a microservice itself. So the data feeder is not actually one, it's multiple scripts that have to be deployed. So I actually need to break down the task to smaller tasks to better represent what's actually going on. And then once I package it, I can deploy it on the cluster. Now, there are certain problems with deploying it to the cluster because, as you know, as we've been through many times, there needs to be a health point. Now, if there's a binary, a Python file that's run as a daemon, it might not be totally suitable for a health endpoint, but I'll have to research how readiness and liveliness probes work outside of simple HTTP requests, if it can be deployed as a TCP port message exchange, or any kind of feedback to the probes saying, yes, I'm a service and I'm alive. And that's pretty much what I have to do today. So create container and maybe find a way how to write the health endpoint. And I think that's gonna take me the whole day. It's Friday, so I hope it's not gonna overflow. And if I see by early afternoon that it's not doable, I'm gonna put a stop to it, and I'm gonna say, okay, that's it, Michael. No more, because your weekend is really important. And I'm gonna end it right there because stand-ups need to be short and to the point. So I'll take a look if there are any questions. No questions, so I'm gonna end it. I'm gonna say thank you for watching. Subscribe, like the video, drop the comment below. If you have any questions after the stream, doesn't matter, just drop a comment below and I'll answer all your questions. Thanks for watching, and I'll see you on our next stand-up.